Okay, then go down. Then let me check another example that they had. About this one, another one that they had, it was the ones in, okay, let me automate. So the second question I had, it was this one. I'm not sure if you guys gonna see it, but let me just like enlarge it. This is one of those examples that you get in unit 5.1. It's this example which looks like this. Then they tell you that example 1, let your v is equals to f of t is equals to 4t be the velocity of an object in meter per second. How far did the object move in 5 seconds? So basically how they like to do these ones, they either do them in table format or they can do it using the integral. So if you're going to be doing it using the integral and doing your estimate, it means you're going to be looking at this 40, then you find the antiderivative of your 40. You see? So the step that they took here is where they tried to determine the area. Then they did their triangles as usual. Then they found the area is included this side, that they got their 15. So for us, I think we're just going to try and use the antiderivative. That okay, if we have an antiderivative of let me see, 0.4, 0.7. If we have an antiderivative of 40, this one, it means we can write it in which region. We can say as usual, we have our 4, then we have an integral sign, then we have our t. So in this way, we know we can use the power rule. The power rule which says we have what? We have 1 over n plus 1 multiplied by your x to the exponent n plus 1. You see? So it means now we're going to be finding that antiderivative of t. This will be the same as having your 1 over 2 multiplied by t to the exponent 2. See? So now if we bring this 4 back to this side, it means we are going to be having what? The 4 multiplied by 1 over 2 multiplied by t squared. Okay. Then it means you're going to be having something like this. Then the 4 multiplied by half, then this is the same as having your 2t squared. So that would be basically the antiderivative. Then we add a page that okay, we found our 2t squared, but we're finding from which region. It's going to be between, what did the question say? Let me just go and look. This short book. It says between how far did the object move in 5 seconds. So it means we're going to be estimating between 0 and 5. You see? 0 is where we're starting, 5 is where we're going to be ending. So it means if we're going to use the fundamental theorem, it means now we're going to have our 2 into 5 squared minus the 2 into your 0 squared. So this is the same as having your 2 into your 25. Then we know this part it's 0, it's going to cancel out. Then this is the same as having your 50, you see. So you can either use this method, or you can go and use the one where you use the triangles and stuff like that. You see, they all give you the same value, which is your 50. As long as like you followed the right steps, then you will definitely arrive at the same. And so okay, let's just do. Okay, I'm trying to remember the other question that that was asked. The other question that was asked, it was the Riemann's rule, which is on 5 unit 5.2. This one, it's those questions that like are on unit 5.1. So let me quickly erase these things. So yeah, no, you guys have any questions on this ones, or you're all sorted? But like, yeah, it's just a matter of you choosing which method works. It's either you can do that one where you do your triangles, or you can do it in antiderivatives, as I've done this one. Then let me just erase this and go to another question as we move up. Okay, so now let me remove this. Okay, on this side. So the other question, if I remember, it was the one where they said, okay, they said estimate, I don't want to paste, estimate the integral of 9 and 1 over x dx by 4 subintervals. Subintervals. So this is where you could know that you're going to use the Riemann's rule, where you basically have to be determining your left hand side and your right hand side. And I'll also give you one of the example that was sent in the group. So first things first, you go and try and calculate. Okay, before you can calculate, let me just do the basics explanations that you know. In your integral sign, this side, you always have your a at the bottom and you have your b at the top. So in order to find your delta x, you know your delta x is given as your b minus a over your n. Then your n is the number of subintervals, which is this 4 here, you see. So how you go about doing this, you will say you have what? You have your 9 minus 1 over 4. Then this is the same as having what? Your 8 over 4. Then this gives you your 2. You see? So yeah, so far I just hope we're still together. Then now you go, let me just edit page. You go and try and draw your table. That okay, it's remember it has to be your x, where you have your x, then your 0, your 1, your 2, your 3, your 4. So it's going to be something that looks like that. Then this is where you're going to be having those x values. Then this is your f of x or your y values. Then you know, okay, you have your 0, your 1, your 2, your 3, your 4. And then now you go and check. The first point that you write this here will always be your a point. You go and check that, okay, what's my a? Your a is this point, this side. It's this one, which is your 1. Then you go and say, okay, I have my 1 this side, but what is the delta x moving forward? Your delta x was 2, which is this one. So now it means you can say you have your 1 plus 2. Let's say you have your 1 plus your 2. Then this is going to give you 3. Then you have your 3 plus your 2. Then this is going to give you 5. Then you have your 5 plus your 2. Then this is going to give you 7. Then you have your 7 plus your 2. Then this is going to give you your 9. See? So these are your x values that you're going to be having. So I don't want you to be confused by the ones that are on the top. So now remember, in order to find your y values, you must substitute your x values into the equation. Remember, you were given what? You were given integral of 1 over x. Then you have your dx. So with this one, is going to be your 1 over 1 is still going to be 1. Then this one is going to be your 1 over 3. Then this one is going to be your 1 over 5. Remember, I'm just basically taking the x values and substituting them where you see your x is this side. See? Then you have your 1 over 7. Then here you have your 1 over 9. Then now we can continue where we're going to calculate our left hand side and our right hand side. And always remember, you have to check your restrictions. Your restrictions, what are they saying? They're saying you must do your estimation between 1 and 9. It means you're going to be starting exactly at which region, which is this one. You see? So now you're going to first say you have your left hand side. You have your left hand side. If you are calculating on the left hand side, you're basically starting where you're starting at 1 and ending at 1.7. But if you are calculating your right hand values, you're going to be starting at your right of 1, which is going to be here, and ending this side. You see? All in all, they're supposed to be 4. Remember, for the first one, I said it's here. When you are having your left hand side, the 4 is up into it's 1, 2, 3, 4. Then on the right hand side, you're starting on the right hand side, which is on the other side of that one, it's your 1, 2, 3, 4. Then now it means on your left hand side, what do you have? You have your 1 multiplied by what? By that 2, which is your delta x. This one that we got here. Then you say you have your 1 multiplied by your 2 plus your 1 over 3 multiplied by 2 plus your 1 over 5 multiplied by 2 plus your 1 over 7 multiplied by your 2. So remember, as I said, this 2 is where you got those your delta x. Your delta x, then you find the value for that one. Can someone quickly calculate that one for us? Yes, we go and calculate the one for the right hand side. Someone to quickly calculate this one for us. Others, come on. Come on. Let's be fast. We still have like a lot of questions.
The left-hand sum is 3.35.
We got 3.35. Then the right hand side, you remember, we're going to be starting at that right, which is here to there. So now what do you have? You have your 1 over 3 by 2 plus your 1 over 5 by 2. Then you say plus 1 over 7 by 2 plus 1 over 9 by 2. Then you can also find the value for that one. It's 1,57. Then we now we have a 1,57. Remember the first answer was this. Then we also have this one. Then now what we have to do, remember we're estimating. We're just gonna say this is gonna give us an approximation of. Then you have your 3.35 plus your 1.57. Then you divide this by 2. Then you say these are approximately, what's the variance? Let's be fast so that like we can do one last one, which is different than
2.46.
You get your 2.46. Is it this one or that one? Yeah, come on. Maybe the proportion. Why am I seeing that notification? Okay. You said it's 2.46. Okay, sorry about that. We have a 2.46. Then that's basically your Riemann rule. So yeah, that's how it is. So let me just like do one last example, then okay, and also show you what other question they might ask you after they ask the one for Riemann rule. Because like I've seen there was this way they would say you have your 4 plus 3, where they ask 2 at the same time. So don't worry, these questions are saved. I'm still going to send them when you're done. Okay, so let's just say now they say to you they say to you that okay, this was like I think it was example 3. They tell you that okay, for the first question you have to estimate the integral between 3 and 1 where you have your 2t by using your 4 subintervals. So then the second question that they would ask, I'll tell you that like use I think it's use areas. Yeah, it's use areas where they say use areas to find the integral between 3 and 1 2t dt. So they would let it be like 4 and 3 at the bottom. So yeah, something like that. So we start with the first one with the same explanations that okay, what do we have? We have this, then you know that this one would be equals to your b, then this one would be equals to your a, and the last one, this one will be equals to your n. So now you go and try and work out the values that like supposed to be included. So now you go and calculate your delta x. That what do you have? You have your b minus a over n, which is your 3 minus 1 over 4. This is the same as having your 2 over 4. And this one will give you your 4 divided by 2 is 2. It's your 1 over 2. You see? So it means your delta x it's 1 over 2. And remember they said you must use 4 intervals. So going to be having a graph that looks like this. It's your 0, then 1, 2, 3, 4. Then it's like this. And remember you have your 0, 1, 2, 3, 4. This is where you have your x, this is where you have your f of x or your y values. Then you go and check that okay, what is your a? Your a is this one, which is your 1. Then it means now you can go and write you have your 1 this side, but now you are adding 1 plus 1 over 2, so this will give you your 1.5, then 1.5 plus 1 over 2, then this is gonna give you 2, then 2 plus 1 over 2, then this is gonna give you 2.5, then your 2.5 plus 1 over 2, then this is going to give you 3. Remember this is the same as having your 0.5. So basically I'm saying my 1 plus 0.5, 1.5, 1.5 plus 0.5, then it gives me 2, 2 plus 0.5, 2.5, 2.5 plus 0.5, then you get your 3. Then you go back and check what was the thing they've given you. Remember you had an estimate or integral between 3 and 1, 2t. So it now means that you have where you see your I'm not even supposed to be using the x here because now we're working in t's, so sorry about that. So here we're supposed to be using the t's instead of x. So it means here you're going to be having a t, this side you're going to be having the f of t. So what do you have? The first one, your 2 multiplied by 1, because now we're basically inputting these values here. So your 2 2 by 1, it's going to give you your 2. Then your 2 by 1.5, 1.5 by 2, then it's going to give you 3. Then your 2 by 2, it's going to give you 4. Then your 2.5 by 2, it's going to give you 5. Then your 2 by 3, it's going to give you 6. Remember, where I'm seeing my t this side, I'm just like inputting these values that you see, but like on this side. Then remember this this just like they've represented in t, but in an instance, this you are looking at your x values and this is your y values. But now we're working in t's. So let me just erase that we are done with that one. Then now we get to the part where we're doing the left hand side and the right hand side. We have the left hand side, then you're still going to be doing the same thing. Remember, you go and check that, okay, they said you're starting from where? Okay, here it is, starting from 1, which is here. So if you're starting on your left hand side, it means you're going to be starting from this region. Then you're going to be having 1, 2, 3, 4, because you're using 4 sub-intervals. Then when you're going to go on your right, you start on the right hand side of that one you've started with. It's going to be your 1, 2, 3, 4. Then you work out those values. Remember, you're going to be multiplying with your delta x of 0.5. After finding your left hand side, you'll also work out your right hand side and get those values. Then you will get the approximation for this as your x plus y values that you would have found divided by 2. As the same way we've done in the other example. So yeah, that's it. So now we are done with this one. We've highlighted the examples on Riemann's. So now I think we're still on 5.2. Still on 5.2. Let me go up. Okay, now the second question, they say use areas to find an integral between 1 and 2, where you have your function of 2t. So remember the first question that like we did, where we had something like where they were saying you have to find your meters. So it's more or less like this one. So you'll see even in this one, you can try and do it in 2 ways. So let's see. The first way, where they would normally do it on a Cartesian plane, if let's see how much it's going to give us. Let me draw this. Okay, they're saying we're doing this one. They're saying use areas to find this. Then we draw Cartesian plane. That okay, going to be here something that looks like this. Then okay, it's between 1 to 3. Then we can say this is 1. It's between 1 to 3. Then you have your 2. Then you have your 3. Then this side, okay, it's okay, given at a function of 2, we can take it at a multiple of 2. You can say we have a 2, 4, 6, 8. So we go to this function that you see here of 2t. Then okay, if we input our x values as 0, it means we're still going to be getting a 0. But if we input 1 into this t, it means now we're going to be having our first point this side. Then if we input 2 this side, we're going to be getting a 2. If we input 3, we're going to be getting what? We're going to be getting a 6. So now you can see that this sort of creates like a straight line. See, like a straight line. Then if it's a straight line, then now you have something that looks like this. But now we're supposed to be finding the area. But like if it's like this, you see that like it's kinda difficult to determine an area of something that looks like this. So that's where you see we can try and split this into 2 shapes. That we can have a square at the bottom, then a triangle at the top. See, just okay, here's a black one. That okay, we have this and the other one at the top. I think now it's easy to do. It's easy to do. So now let's check. Remember the area for this one we can just call it, let's just call this one 1 and this one 2. So we can say the area for 1, it's your length times your breadth. You see? So that thing. Alright, so what do you have? You have this region. You can read it as you say. How we go about reading this, you say the distance from here to here would be your 3 minus your 1, then you would have your 2, then the region from here to here, it's your 2, so you're going to be having your 2 by 2. Then this is going to give you 4. Then now we go to the top part. We go to the top part. That okay, the area for number 2, what we have a half base times height. Yeah, then what is our base? Our base, we've worked it out that okay, it's this one. Our base, we've worked out that it's from here to here, which is the difference, that is your 3 minus 1, which is your 2. Then our height would be from where? Our height will be from this region, will be from here to here, where you can say it's your what? It's your 6 minus your 2, which is going to give you 4. So now we've already found the other values that are missing. We can go and calculate that we have half into what is our base. Our base is 2 multiplied by height, which is our 4. You see, so this is the same as having half of 8, which is 4. So it means you can go and say the total area would be equals to that 441 plus 442. Then this is going to give you 8. So that's one way where you can do this example, where they say use areas to find this. So you can do it this method, or you can go again and do it with the method where you find the antiderivative. So let me just quickly wrap this thing. That okay, we got the 8, then it means if we try and use the antiderivative, we must also be arriving at 8, unless we've done something wrong. So you see, with unit 5, at least at the most you have like two methods of doing the calculations. So you just have to make sure that like you're good in one. Then what do we have? I forgot the thing. Okay, it was like this. First we have to write its antiderivative. It was like this. So now what we have to write is the, how can I do this thing? Then you have to find the antiderivative of this. You still follow the first same steps. That okay. What do you have? You have this. This thing is off. You have your 2t. Then you know you can transfer this 2 to this other side, that you have your 2 an integral of t. Then you know this is the same as having 2 to the exponent 1. Then you use the power rule. You'll see that you still go it back and get your answer as your t squared, because the 2 is gonna go to that side and cancel with the other one. Then now what you have to find, you have to find for this one, but at which region. Remember, it's between 3 and 1. So it means now you have your 3 squared, because remember where you see your t, you input your 3 minus your 1 to 1 squared. So this is the same as having your 9 minus 1. Then you still get to the same answer, that it's your 8. So we got the 8 this side. Then when we were using that method where we had to do the shapes, you get your 8. So yeah, whatever method that you feel that you're comfortable with, you can use it. Or even if you're fast enough, you can use both and verify. Then I think, yeah, with I think we've done 5.1 and 5.2 examples, and now we're just going to be covering those ones that you would find in 5.1, 5.4 and 5.3, because those ones is where you're mainly going to still using the fundamental theorem. Then, and I also find the fundamental theorem quite easy and straightforward. So, okay, let me do this. Just mark everything out and go back. So yeah, and I also forgot to say that, yeah, you guys must remember that you must go and watch that video that, like I said, that you must watch on 1.2, because like you must remember how to sketch the function, because like if maybe perhaps you have been following the scope and the work order that like I've once sent in the group, it means by now you are able to sketch each and every graph. You are able to tell the domain, then the other ones, because like you'll see in each and every unit that you're going to write on, you're going to be sketching. For instance, in unit 3.5, what's happening? Yeah, you can have you can be asked to sketch or solve an inequality by using graphs. Then in 3.6, you're still going to be doing the sign graphs, then you can sketch them. Then in your 4.1 to 4.3, you'll still be asked to sketch and also use the number lines. And yeah, and in unit 5, is it unit 5 or 6? I think I'm written. Let me just quickly check, because like I remember finding the area of an enclosed graph or something. It's either 5.4 or 6. Let me quickly check the site. Oh, okay. that one, it's in 6.1. So luckily in unit 5 you just like have to do the integrals. Then yeah, the only sketching that you have to do is the Cartesian planes and those shapes. But in unit 3.5 to 4.3, yeah, you have to go and watch that video. I remember making a quick video showing you how you can go quickly remember the parent functions, stuff like that. So let's check another example that we can do. Examples we can do. I think so far we've covered the examples that we need. Yeah, we're just gonna go to the ones where you mainly have to find an integral, the fundamental theorem. We've discussed it. Okay, so now we're just going to be doing some of the examples from the book. I have this book here with me. Let me just quickly check. Okay, let me do this. That the thing, calculate the following definite integrals. Okay, let me just write them down. Yeah, write them down, then you guys can choose the ones you think might look difficult, then we explain them, then we go back to the other units and see what we can try and discuss. So the first one, what are they saying? They say calculate the following definite integrals. So the first one that they had was that 1 between 2 and -1. Then they had that t squared minus 1 dt. Then the second one, they had this one which is between 1 and -2. Then you have your 2 minus your x to exponent 1 over 3 or dx. Then the third one they had which is starting from 1 to 2. Then it's your x over your root of x squared plus 9. Then you have your dx. Then the fourth one they had your cos into your 3x multiplied by your e to the exponent to your sine into 3x. The fifth one, which is your v, it's where they had your pi over 2 to minus pi over 2. Then this was your cos of your 2x dx. Then the last one, which is your sixth one, it's when they had 1 between -1 and 2. Then you have a 3 to the square root of x over square root of x dx. So these are the examples that they've given you. Then these are the examples that they've given you. Okay, let me erase this thing. So yeah, I think you guys can choose then which ones do you want us to do. I think we can do 3 or 4. Then we move to other parts like your unit 4 or the other ones that you guys think we need to discuss. Which one looks like it's difficult?
The third one.
Okay.
So we can't reduce moving fast.
You can't see the screen or what?
You're moving fast.
Oh, I'm moving fast. Okay, let me just wait for a moment. These are the first 3. Then I'll leave it for a while. Then move to the second 3. Okay, let me show you the last ones. The last ones are these ones.
So please go down. I can't really see of 5.
Number 5 is called this one. It's let me write this one. I think it's 2. Because of your 2x.
No, I mean the upper and the lower limit.
Which one? For this one?
For number 5.
That's a pi over 2
Oh.
and minus pi over 2. Okay, so yeah, since you guys can choose, then I'll just start in this order. Then I'll see where we're gonna stop. Then yeah, we go to another theme. So I'm trying to at least maybe touch 2 to 3 examples on each theme so that you know okay how we go about doing that. Then the other examples, I think yeah, you'll just have to try them on your own. Then after this one, which
7.
yeah.
So there was a request for you to start with number 3.
There was a request for me to start with number 3.
Yes.
Okay, 3 particularly which ones?
Sorry?
3 particularly which unit?
Number 3.
Number 3. Oh, you mean I thought you were saying unit 3.
No. Be in these examples.
Oh, okay. Excuse. I thought you were saying theme 3. Oh, number 3, it's this one, eh? You're referring to this one, eh? The person
Yes.
is fine. Okay. So yeah, we have things that looks like this. So add a few pages. Number 1, number 2, number 3. Okay, so now I'm just gonna start explaining how you go about doing this thing, because like as I said, you can either use the chain rule or the U substitution. So in my opinion, I think the U substitution is definitely like the easiest one to use, as mainly you'll see you'll have to use the power rule a lot. And yeah, I know there was a person that said like I think it was the assistant teacher or something, that you guys are not supposed to use the U substitution. But like, yeah, someone went to the lectures to confirm, and they said they do use the U substitution, and it's also there in the textbook, you see. So which means now you can just like use the U substitution, but like if you were using the chain rule and you got used to the chain rule, you can continue with the chain rule. But like the U substitution, I just think it's just straightforward. So the rules now say if you're going to be using the U substitution, you basically look from an area or a region where if you replace it with a U, that region is just going to give you a clear derivative. So if you the first one is straight up a power rule. So let me just like try with the first one, so that like you guys can understand the things, rather than just like going straight up to the ones that are difficult. So let me quickly check this one again. You had number 1, which said you have something that looks like this. You have your t squared minus 1, then you have your dt. So mainly with this one, you can see that you straight up can use the power rule, which says what you have your 1 over n plus 1 multiplied by your x to the exponent n plus 1. So it means what are you going to have? You're going to have something that looks like your 1 over 2 plus 1 multiplied by your 2 plus 1. Then you know this is going to give you what? This is the same as having your t to the exponent 3 over 3. Then the 1 will become your minus t. Then that's the final answer. But now you must remember you have to estimate between 2 and minus 1. So it means now you're going to be having your 2 cubed over 3 minus 2 minus into, then you have your 1 cubed over 3 minus your minus 1. So you get the final answer for this. Then yeah, that will be the first one, which is straightforward. Then the second one, I'm tired so my one the second one, what did they say? They say they had something like this. You're between 1 and minus 2. Then you have your 2 minus x. Then you have 1 over 3. Then you have your dx. Then you can say remember the step that like, okay, whichever region that you are choosing, it must have a clear derivative. And you see, if we were to choose this region here, it has a clear derivative. It's what? It's minus 1. So you can say let du is equals to your 2 minus x. then you continue and say your du would be equals to what? The derivative of this, which is your minus dx. So now you're trying to write dx in terms of du. It basically means you're just dividing by that minus 1, because remember the derivative of minus x is going to give you the derivative of 2 minus x is going to give you minus 1, which is the one I'm indicating this. So this is the same as having your dx is equals to minus du. So as we said, we're going to be replacing that 2 minus x with u. Then we have that 1 over 3. Then remember, instead of having this dx here, we're going to replace it with minus du. You see? But now it means this minus, we can just like take it to the other side and to work with whatever we have, then bring it back later when we are done. We have 1, we have minus 2, we have u, we have to the exponent 1 over 3. Then we continue. Okay, we still have that du, but whatever you do, don't forget that negative that you have on the other side. So what do you have? You can go and we focus on this region here, and you can still see that whatever we are doing, we're still using the power rule. The power rule is just simple. What are you going to have? You're going to have your 1 over 3 plus 1 multiplied by your u to the exponent 1 over 3 plus 1. See, this is the same as having your 1 over 4 over 3 multiplied by your u to the exponent 4 over 3 to the exponent 4 over 3. Then mathematically, you know, if you have your 1 divided by your 4 over 3, you can write this as 1 multiplied by your 3 over 4, which is this part to the side. Then you'll say you have your 3 over 4 multiplied by your u to the exponent 4 over 3. Then I remember the negative sign that we took here. Then now we must come and place it back, that we have minus 3 over 4 multiplied by our u to the exponent 4 over 3, but our u, we know it, we can say the final answer is minus 3 over 4 multiplied by the u was it was 2 minus x into 2 minus x to the exponent 4 over 3. Then now you have to find a region where you have minus 3 over 4 multiplied by 2 minus x to the exponent 4 over 3. They've given you the regions that like it's between your 1 and minus 2. So you're going to be doing the same, the fundamental theorem. You input this one into this, then you deduct the other ones. We're just going to be inputting this minus 2 into the whole thing again, saying you find the answer. So let me continue with the other one. The other one, what did they say? Which is the one that you guys wanted? You have one which looks like this. I think there's someone whose mic it's on. You can please switch it off. X squared plus 9 your dx, you see. So yeah, now we go again and look that, okay, where can we let like our portion of the function be u, and also you see if we let that part be u, does it have a clear derivative, and does it make the whole thing much easier? You can see where we have our x squared plus 9, this gives us a clear derivative of what? Of 2x. So it means now you can go and say let your x squared plus 9 is equals to u. Say you're going to write your du, which is your derivative, is equals to your 2x, which is the derivative of this, dx. So you do the same thing, you write your dx in terms of du, you have your dx as equals to, you divide by that 2x, divide by that 2x, then you'll be getting your du over 2x. Then we continue. I'll add up this thing. We continue since we had our dx is equals to du over 2x. Then now we can go and try and see what do we have now. You will see that we have this. We have our x over root of u. Then remember the dx is going to be changed into the du over 2x. Then you see this one and this one, they cancel, so it means now you can have your 1 over root of u multiplied by your du over 2. So still have this. Yeah, let's just not forget we have 2 and 1, 2 and 1. So now you see here it's the same as having we can have the 1 over 2 du. So it means we can take this 1 over 2 to the other side, then we can have something like 1 over 2, and we have between 2 and 1, then 1 over square root of u du. You see, then we can further simplify this part again, that okay, what is our 1 over okay, let me add a page. We can further simplify this further, that what is our 1 over square root of u. This can be written as the same as having your u to the exponent minus 1 over 2 du. Then you see, back to the same thing that we know, which is using the power rule. So you now know that you're going to be having your 1 over minus 1 over 2 plus 1 multiplied by your u to the exponent minus 1 over 2 plus 1. So you know it's going to get, you're going to get your 1 over minus 1 over 2 plus 1, it still gives you 1 over 2, then multiply by your u minus 1 over 2 plus 1, still going to give you, it's going to give you 1 over 2. Then as I said, if you have your 1 divided by if you have your 1 divided by 1 over 2, this is the same as having 1 multiplied by 2 over 1. So it means this side you're going to be having your 2 multiplied by u to the exponent 1 over 2. So now you must go back and check that, okay, what do we have? We still have this 1 over 2 here that we shouldn't forget. You see, so we're going to transfer it back to this side. So it means now we're going to be having 1 over 2 multiplied by the ones that we've been working with by 2 u to the exponent 1 over 2. These ones, they cancel one another. Then you are left with what? You are only left with u to the exponent 1 over 2. Then what is your u? Yeah, u is the same as having your x squared plus your x squared, this thing is off, x squared plus your 9 to the exponent 1 over 2. What do you realize about this? It means you can use a cubic root or root. Then you have your x squared plus your 9. Remember, you were finding from which region? From 2 and 1. You do the same. You go and substitute 2 into this formula. Then you minus your this formula, but you'll be substituting your ones. Then you find the difference as your answer. So yeah, that was number 3. Remember, we only had 6.
So can you use the other method for that one?
For the chain rule?
Yes, please.
The chain rule, and I'm also not that good with it. I've used this one. Unless someone, if it's good with the chain rule, and then they can try to assist us with it.
Okay.
Which one are you using? Are you using the chain rule? It means you're strong. You're using the chain rule. You can use it, but I've never invested much time in it, because I just found this one much quicker. But I do remember when I was studying this theme, how many hours did I take? I think it took me close to 9 hours in the theme 5 and 2, because I was just studying them together. So the moment I realized the U substitution was easy, then I was just using the U substitution, then spending a lot of time doing examples. You see, so sometimes I'm surprised. Someone will say, I only did theme 2 and 5 for 2 hours and expect to at least maybe get good grades. So you must make sure that you spend enough hours on theme 2 and 5. And you can even see with the marks allocation that they've shared on ClickUp. I think this theme 5, was it 15.5 or what? Something along there. I'm not sure, but I think I remember saying 15.5 or something. So you just have to make sure you don't miss that. Then do we continue with this example, or do we move to another theme? Because so far we've already done 3 on this one. We've done 3 on each. What do you guys think?
So please do number 5.
Okay, number 5. What was it saying? Let me check the book. Oh, okay. You mean the one for the pie? It was saying you have. Okay. Let me just some few seconds. I just want to change the stylus because this one is dead. It's dead. Where's the other stylus? I'm going to use my finger now. Let me check the box. What's the sound? Okay, let's just hope it has some power, because like I was using it in HVH around 1, 2, 3, but like yeah, it's on. I think it has. Let me check and try to charge this one also. So I'll be changing them. So what do we have? Let's see how it's going to write. Okay, seems like it will do. So we continue. So we had what was that? Okay, we had this. Then it was pi over 2. Then this side is minus pi over 2. Then we had cos of 2x. Then we had dx. Okay. Then now we go and follow the same procedure. That okay, we can let our 2x be equals to the u. Then you can say your du is equals to u is equals to your 2 dx. No, why am I confusing myself? Let me do it like this. I said your u is equals to your 2x, then your du is equals to 2 dx. Then you know your dx will be equals to your du divided by 2. Then okay, since we have this, we're going to go back and substitute that. Where you see your dx, you'll put this. Where you see your 2x, you go and put this. Then let's just check what do we have so far. We're going to have this. Then this is where we're going to go pi over 2 minus pi over 2. Then we have cos of u, then multiply by the du over 2. As I said, this you can note this region that it's the same as having a 1 over 2 multiplied by your du. So which means now you can say we have this, then we can just write that 1 over 2 from this side. Then we still have the cos of u, but now we're only left with du this side. So this one is straight up simple. You know, this cos of u is just the same as having your sine of u. So it just means your answer is going to be your 1 over 2 sine of u. You see? So now you go and substitute that one, that you have your 1 over 2, your sine of 2x. Then you go and check that okay, you have this, but now you have your 1 over 2, your sine of 2x, but now you're working from pi over 2 and minus pi over 2. So what you're mainly going to be doing, since this is the last one, you're going to say you have your 1 over 2 remember you have to use the, what's this thing, the fundamental theorem, into your 2 multiplied by your pi over 2 minus your 1 over 2 your sine into 2 minus, what did I write? Okay, 1 over sine into your, into your 2 minus pi over 2. Then you get that answer. So that's how the last one would be like. The last one would be like. So far, let me check. Yeah, we did this one, we did this one, we did this one, we did this one. Then you guys can go and try this one and this one with the U substitution or whatever method that you wanna use. Then yeah, which theme are we moving to now, since we've done with theme 5?
Sorry to take you back, but yesterday I sent you a question and you said we'll do it in the live session.
Okay, what kind of question was it? Maybe I'll remember.
It was a graph.
It was a graph?
Yes.
Let me check. Well, what's your name? Maybe I'll check with your name and see.
I'll just send you a message again.
Okay, just send it to me again now so that I can check. We started with that one.
Oh, okay, it's fine.
We started with this one. It was the one where you were using the trapezoid. So yeah, let me just quickly explain it to you, and also the ones that were not there. Even though I even asked you guys to, like, I'm not sure if you guys do this such examples, but yeah. Did you guys ever do something like this?
It was in the practice problems.
Oh, it was in the practice problems?
Yes.
Okay, so yeah. Let me just try to quickly edit again. Okay, so we have something like this, and I said, okay, this is where you're going to be using your areas for the shapes, and you can see you have these shapes that I'm about to indicate, which is this one, which looks like your first trapezoid. Then the second one will be this one, which is your second trapezoid. Then the third one would be this one. The third one would be this one. Then the fourth one would be your square, which is this one. So the formula or the area for trapezoid. So you're going to say you have, what's the formula? It's half into your B, which is your wideness of your block. Then you have your H1 plus your H2. Then you're gonna go and say, okay, you are doing from x1 to x2. I'll say from x is equals to 1 and your x is equals to 2. Then what are you going to have? You're going to have your half into, what is that wide of your block? It's from this side to this side, which is 1. Then you can say you have your 1 into, then you say you have your h1 plus your h2. Your height 1 and height 2, where do you get them? You get them this side that okay, you have your height 1, which is your 1, and the second one, which is this side, which is your 2. You see, so now it means you have your 1 plus your 2. Then this is the same as having your half of 1, that is 0.5 into 3. Then this one gives you your 1.5. Then now we are done with this one. We're going to be moving at a region from where? From quickly erase this one. And quickly erase this one. We say we're going to be moving from origin from x is equals to 2 to x is equals to 3. Then we know the formula is half into your b. Then you can even use the 2 and 3. You have your h2 plus your h3. Then you go and check that okay, on this one, what are the heights? The first height is this one, which is going to be your 2. The second one is your 1. So you have your 2 and 1. So it means you have your 2 plus 1 this side. This is still 1. This side you still have your half of 1, that is 0.5 into 3. This one you still have your 1.5. Then you are done with the second one, which is this one. Then now you move to this last one. This is where, from which region? Let me do this. Okay, you will say, what do you have? You have the one for the 8 which is your half into your b. Let me just quickly write the region. Remember the last one, it was from x to is equals to 2 to 3. Then we're going to continue and say, now we'll continue from where? From x is equals to 3 to 4. Because the last one we were at 3. From 3 to 4, we go and check the height. 3 to 4, we have the first height here. We have the first height this side, but okay, what is the height? You will say it's 1 and 2. No man, why are you doing this? It's 1 and 2. So it means now, what are you going to have? You're going to have your half into the wideness of that block is still 1. Then is it 1 and 2? Yeah, it's 1 and 2. I feel like it's just repeating 1 plus 2. Then this we've already done it, it's 1.5. So now you're already left with that small shape at the end, which is a square. Then for that square, you know the area is equals to your length times breadth. Then you go and check that okay, what do you have? You have this region from here to here. This is 2 by 2. Then you go and you say you have your 2 by 2, which is going to give you from. Then remember for the area for the trapezoid. Then over the trapezoid, it gave you your 1.5, but there were 3. So your 1.5 is going to give you your 4.5. So the total area would be your 4.5 plus your 4. Then this is going to give you your 8.5.
Thank you, sir.
Okay. So yeah. Am I missing any question or something that you guys need to know? Because if maybe you sent a question and I forgot to include it, then yeah, you can just like resend it again on WhatsApp, then I'll do it. Yeah, I was just checking which unit do you want us to do for now, because like now I think we've done at least 3 on unit 5.1 to 5.4. because I can tell by now at least 3.6. Everyone now they are sorted unless they're the new ones. Then which one can I say would be difficult? I don't even know, because like we finish these things again and again and again. So you guys don't know what you are also struggling with.
So are we still gonna have another session, or this is the last one?
Yeah, this was the last one for the guys that weren't able to attend the other ones. Then the sessions mainly for now is just going to be sessions that like are based on questions that students ask, or maybe if I had some challenging questions, I will just like save them up. Then when we have a session, we're just going to go through those. But Mina, I didn't mind, since I see like you guys are going to be writing in the 6th. We can even have a session each and every day up until you guys write. So that like, yeah, you just come with your questions, the longer ones preferably, because there are some I can't be doing lots of individual videos. Even my storage this side it's out. I tried buying, what's this thing, SDs. So I mean, the other day I even formatted my entire phone, not knowing what I was even doing. So yeah, I would prefer that, like, if maybe perhaps we have something like this, then the other ones I want to try the board one, because like Korea was supposed to deliver the whiteboard. So I want to see if that one is not going to be first or what, because like, yeah, then at least we can change methods. And from this one, let me just quickly check if maybe there isn't anything I could add. On my side, I don't know what to even add, because like I think this ones we've done them again and again and again. Yeah, because like I think what you guys need to do now, you need to have something like a checklist. Let me see, there was a page. Where's the page? Yeah, you need to create yourself something like a like a checklist, and just like tick it. It's like you go, then you know you're going to start is theme 3 to theme 5. So on theme 3, you'll be required to solve, I think it's what are those things, equations and inequalities and sketch. Then 3.6, that's where you are going to do the periodic calculations. Then you can also be asked to sketch graphs and also do your estimating. Then in your 4.1, they will still even ask you to sketch, determine the domain of a function, then ask you to do the first derivative test, second derivative test, draw number lines and determine if whether that graph or whatever the function, where it's increasing or decreasing. And remember, if they've given you a function and they ask you where it is increasing or decreasing, this is where you use your first derivative. Where they ask you about concavity, you use your second derivative. It means even when you're going to write the number line, you're going to be using the first derivative. You see? So lastly, what they could also ask you is, remember the graphs where I said like they could ask you to draw a graph with properties. So it's also one of those. Then the last one would be your local extremes.
Sir.
Yes.
Hello.
Yeah.
I guess I wanna see na. Ke bona tsa di trapezoids.
Oh, one nine.
That is Tjela tja di area.
Oh yeah, re stopile ke re discuss. A o nkwele ke bolela?
Oh, but maybe le discuss le bolela.
No.
Ke re fan le wala like le.
Oh no, I'm just like explaining how you have to make your own checklist. You see, because like I think it's quite simple if you're making your own checklist. That okay, like perhaps in theme 5, you know, you have to do integrals, antiderivatives, fundamental theorem. You have your Riemann's rule. You have your areas. You have to do your estimation. You have to know your sketching of graphs. You see how many things I've mentioned. So when you go down and see, okay, out of all the things that like I've mentioned, how many are you good in? Because like sometimes it happens like you are just practicing around 1 or 2 examples which might be on unit, let's just say maybe unit 5.1 and 5.2. So this is how you mainly go and try and make sure that okay, I've covered everything. So I think on Saturday my schedule is open. I'm just gonna write the learning objectives down and look for examples again that are going to be matching those from the past papers. It can either be exams or the semester tests themselves. Then we're just going to be going through those until we are done with everything.
Okay.
So at least, yeah, as long as like we're done with one, if we're doing 4.1, we're just gonna do 4.1, and I'm going to write those learning objectives down, and okay, for each and every, I'm going to try and put like an example in between, so you know, okay, when we were doing this unit 4, with this particular example, I wasn't understanding those ones. Then you know, after the session, you can come and ask me that okay, when we were doing this type of questions, I didn't understand, so that I just like give you those type of questions. Then you practice more on those. Then you fix your mistakes. You see. So this is exactly how you're supposed to be studying. And also one another thing, I don't know, it's like you guys open the slides without even having to check the videos, because like I thought the first thing that you have to do, you go to the Google Drive and check some of the examples. You even see that like I've broken it down into the units, that on units, because sometimes you get the person that sends you the exact example or a similar example that like you've already covered in a video format in the Google Drive. So to me, I don't know what's expected. Am I supposed to make another video or what? You see, so just make sure that like when you go to a particular unit, you go to the drive and check. The videos are not that long. I've tried to at least maybe keep them short to a minimum of 7 minutes and 30 seconds. And you will see that like each and every theme, I try to at least also cover 1 to 3 examples. You see, then if maybe you have some examples of your own, yeah, you can send them to me, then we'll also discuss those. But on Saturday, I heard you guys, there are others that like are writing. I don't know from what time to time, because like I was just thinking that like we were mainly just going to be having, I don't even know how many hours, but like yeah, just go through the the entire examples, just adding and also checking the learning objective, then do as many examples as we can. So if there isn't anything that you guys want to add, then I think I'll just like text the session here, unless if maybe you guys want an explanation on something, then yeah, I'll just like wait for like 2 minutes, then log off, because I'm tired, guys. I've been tutoring since 1, and I have to tidy up my office, then go to my place. But like I'll just like wait for 2 minutes, then if you guys don't have any questions, then just gonna end the call here.
I think for today we're fine, so.
Okay, so thanks. Then
we'll see the other things on Saturday.
Okay, it was nice talking to you guys. I hope that like the preparations they do go well. And yeah, I hope you guys get distinctions, because like I don't expect anyone in this group to get lower marks or someone outside this group perform better than you, because like you basically have everything. But I'm serious, you guys have everything. You have everything. Examples, textbooks, Google Drives. I'm also here. You can send questions anytime. So nothing is stopping you. If you want your 100%, it'll just be mainly based on your efforts. If you're putting too much effort. Yeah, if you want 100, then you can get it. There's nothing stopping you. But like I know, okay, one thing I forgot to mention, when you get to section B and C, ensure that like you always make what's the thing? Make sure that you conclude. Because sometimes they will even give you a half mark for just like conclusion. So I don't know how the memo is going to be structured, but in the past I've known that like in the longer form questions, like your section B and C, you have to make sure that you do your conclusion. Like for instance, where they were giving you something like a function, you did your number line, you have to do those the conclusion that your f has a global maximum whatever, then you also write the values, something similar like that, just to make sure that like you don't cry when they deduct your half marks and the other ones. So bye bye guys, bye bye.
Bye. Thank you.
Sub.